This is our last reaction of aldehydes and ketones. And this reaction is called the acetal formation. In this reaction, we have an aldehyde or a ketone reacting with an alcohol, and they produce a product that is called an acetal, or they could also produce a product that is called a hemiacetal. And so what I'm going to do is draw this reaction with a ketone, even though it works for either a ketone or an aldehyde. And we are going to react this ketone or aldehyde with two alcohol molecules. I'm going to draw them with their line structure like that. This reaction requires catalyst from an acid. So you could see H plus written underneath the arrow because it's a catalyst. Or sometimes you could see H2SO4, which is the formula for sulfuric acid, which is the acid that we usually use for this reaction. Or sometimes maybe you could see H3O+, which is an abbreviation for acid. Or sometimes, if people are feeling really tricky, you could see somebody just write the phrase low pH, which indicates that the reaction is taking place in an acidic solution. And so in this reaction, and this is a pretty magical looking reaction, what happens in this reaction is that our ketone or aldehyde, which I'm going to redraw over here, that ketone or aldehyde carbon-oxygen double bond is actually going to open up kind of like a flower. Now I'm going to draw two oxygens on there because there will be two oxygens on there ultimately. They are both not going to be from the same ketone. But for now I'm going to draw them both like this. So they're going to open up. It's going to open itself up just like a flower. And these two alcohol molecules that we have are going to attach themselves, not the whole entire alcohol molecule, will attach themselves to the oxygen atoms that have opened up from the ketone or aldehyde. And so I'm showing those in blue. So we can see with the color coding, you can see the components that in red that came from the aldehyde. You can see with the alcohols, one of the alcohols kept everything but its hydrogen from the OH. The other alcohol lost its whole entire OH. So together, those two alcohols, the parts that they lost, add up to a water molecule, HOH. This molecule that we produced over here is the acetal. The acetal is a type of functional group that is characterized by the carbon bonded to an oxygen, which is bonded to a carbon, which is bonded to an oxygen, which is bonded to a carbon. So it's a pretty complicated functional group there. It's a carbon bonded to an oxygen, bonded to a carbon, bonded to an oxygen, bonded to a carbon in a pattern like that. The other possibility for this type of reaction, we're going to use the same ketone or aldehyde again. Again, this would be either a ketone or an aldehyde. Our other possibility is that we react with only one alcohol instead of two. Same conditions, so we have acid catalyst, and you could see it in any of those ways, H2SO4, H3O+, low pH, whatever. When we come to the products over here, same thing. We're going to take our original aldehyde or ketone. We are going to open up that carbon-oxygen double bond like it's a flower. We are going to take the alcohol molecule and attach it to one of the oxygens. Let's make it like that. But since we only have one alcohol molecule, we cannot put a second alcohol molecule out here. Instead, we will put the hydrogen from the OH. This molecule is called a hemiacetal. Hemi meaning half, so it's a halfway acetal, and it is characterized by the HOCOC functional group. HOCOC. I do want to point out to you that in order for a molecule to be an acetal or a hemiacetal, only one carbon, excuse me, I said that backwards, only one hydrogen can be attached to an oxygen. So for the hemiacetal, this must be a carbon if the other one is a hydrogen. So this HOCOCH, this is not either an acetal or a hemiacetal. So the formation of the acetal is a pretty tricky reaction, and in my personal opinion, it is the hardest reaction that we do this quarter. There's nothing that is trickier than this particular reaction, which means that we need to do a number of examples to make sure that you really understand how to do this. Lots and lots of practice. So we're going to do one example right here, and then we're going to move to a worksheet that has some more examples for us. And I'm trying to mix up the acid so you can get used to seeing a variety of different things. So here is, actually I wanted to do two alcohols. Here is our reaction. We have an aldehyde, we have two alcohols, acid catalyzed. What I want you to do is just start by drawing that aldehyde just exactly the way that it is. And then I want you to take that carbon-oxygen double bond and open it up like it's a flower. Double check how many alcohols are we adding to this molecule. We've got two of them going on there. So that means that we are going to add the carbon chain from the alcohol to both of the oxygens of the acetal. And we do also make some water here, but your homework is not asking you to list that water possible byproducts, and you don't even need to worry about it.